This is a very conceptual question. Here's a man with a bag in his hand. He falls from a height h. He starts falling from a height h. When he reaches a height small h from the ground, he realizes that the ground below is very hard. So he sees a pond nearby at a distance x from the line of fall of the man. So he decides to throw away his suitcase in the opposite direction so that he falls in the pond. He's a very intelligent person and he knows a little bit of physics, due to which he knows that he can do it. So the question is, with what minimum horizontal velocity should he throw the bag with respect to himself on the other side so that he himself falls in the pond? The second part of the question is, where does the bag land? So let us solve this question. For the first part, the man free falls a height h minus h. So we can directly write down its velocity to be root over 2g h minus h, because initial velocity was 0, acceleration is equal to g and displacement is equal to h minus h. We get the final velocity by v square is equal to u square plus 2as to be root over 2g h minus h. So the final velocity, that is the velocity at this point of man, is root over 2g into h minus h. Now when the man throws the bag, he is already going down with velocity v. Now he throws the bag relative to himself with a velocity v dash. He throws the bag with respect to himself horizontally, that is v dash. Now the velocity of this bag with respect to ground will be velocity of this bag with respect to man plus velocity of man with respect to ground, that is v. Now in this process, this man also acquires a velocity v double dash on the right side. This has to happen because when we consider this system of man and bag, there was no horizontal force acting on this system in the horizontal direction, due to which the momentum of the system of bag and man in the horizontal direction should remain conserved, because momentum in the horizontal direction can change only due to a force in the horizontal direction. So because of a lack of force in the horizontal direction, we can conserve the momentum of these two objects. Initially they were falling in the vertical direction, so the initial momentum of these two in the horizontal direction was 0. So the final momentum has to be 0 again. So when this was imparted a velocity in the left direction, man acquired a velocity in the right direction so as to balance the momentum. This bag is of mass m and this of mass m, so we get mv dash is equal to mv double dash. So we get a relation between v dash and v double dash. Now we know that we want to find out that what is the minimum velocity imparted to bag, that is what is minimum v dash, so that man lands on pond. For that we need to find out what is the minimum v double dash so that man falls in the pond. And now we can first let us find out the time which the man takes to fall to the ground. That is a vertical direction motion and that is independent of the horizontal velocities imparted. Therefore for the vertical direction motion, initial velocity now was root over 2g into h minus h, acceleration was equal to g and displacement is equal to h. So the time taken can be found out as s is equal to ut plus half vt square. Therefore displacement h is equal to root over 2g into h minus h into t plus half gt square. This is a quadratic equation in time whose solution can be easily found out. So the quadratic equation we get is gt square by 2 plus root over 2g into h minus h into t minus h is equal to 0. So we get the time as minus of root over 2g h minus h plus root over, we take the plus sign because negative time cannot be negative, plus 2g into h minus h plus 2g h upon g. So this is our time. mv dash is equal to mv double dash. So the time we get is, time is equal to root over 2gh minus root over 2g h minus h upon g. Now for the horizontal direction motion of the man, horizontal direction motion, we need to cover this x displacement in this time t. Therefore his velocity on the right side was v double dash. Therefore v double dash into t equals x. Therefore v double dash is equal to x upon t. Therefore we get v double dash is equal to x upon x into g upon root over 2g h minus root over 2g into h minus h. Now we know that v dash is equal to mv double dash upon m by momentum conservation. So we multiply this by m upon m to get the minimum velocity to be imparted to the bag by the man, so that man lands in pond. Now the second part of the question is, where does the bag land? For that part, there are two ways of solving the question again. One way is quite easy. I'll tell you the difficult way first, which most people will use. They know the horizontal velocity v dash of the bag. They know the vertical direction velocity of the bag. They'll find out the time taken for it to fall and then multiply that time by this v dash to get the displacement or the distance where it falls. But this method is very lengthy and useless. The better way is that you use a little bit of your extra concepts which you have learned of center of mass. Now for this system, there was no external force in the horizontal direction. So we again go about thinking about the sequence, because we have been asked about displacement. So we again go over that sequence, that when net external force is 0, then the acceleration of center of mass is 0. Let this be the system. The net external force in the horizontal direction is 0 on this system. Therefore the acceleration of center of mass in the horizontal direction is 0. The initial velocity of the center of mass of the system in horizontal direction was 0. Therefore the displacement of center of mass of this system will be 0. So when these two objects fall to the ground, this was the line of motion. Man falls to the pond, that is at a distance x, and this bag falls somewhere here, that is x dash. But we know that the total displacement of the center of mass should be 0. So we write the displacement of center of mass equation, that is equal to m into x, let this direction be positive, plus m into minus x dash, that is equal to 0 upon something. We do not care about that. So we get x dash is equal to mx upon m. So this part we can get the direct answer directly, that the displacement of the bag, or the position where the bag lands on the ground, is at a distance of mx upon m from the line of fall. The answer to the velocity minimum to be imparted to the bag was m upon m into xg upon root over 2gh minus root over 2g h minus h. So final answer stands as, this is the velocity minimum to be imparted to the bag, and this is the distance from the line of fall where the bag lands.